You're good.
This is a story of a mosquito. This is an enzyme in a mosquito called acetylcholinesterase. Or
Acetylcholinesterase.
eyebrows, please. Thank you. All right. Right. So this enzyme breaks down the chemical acetylcholine. The chemical acetylcholine is what's responsible for making your muscles fire. If you have acetylcholine in your muscles are tensing. So you actually need acetylcholinesterase to break down the acetylcholine in order for it to relax your muscles. This is what acetylcholine looks like. Okay? It interacts specifically with amino acids in this thing. Right here. So it acts specifically with this amino acid R group.
Are these sodium
No. This then breaks down this acetylcholine, and mosquitoes can relax their muscles. A researcher found an insecticide. Right? This insecticide doesn't fit on or attract to that amino acid, but this amino acid over here. As you can see, this one's hydrophobic. This one has lots of reds and blues, which are oxygens and nitrogens. So this one has a fairly hydrophobic interaction, but interestingly, this insecticide fits inside of that active site. If it fits inside of that active site, guess what cannot?
The other one.
It's supposed to.
The acetylcholine. What happens to the mosquito?
It tenses up.
It tenses up, and can it untense?
No, and it can't.
It paralyzes, and what happens to the mosquito?
It dies because it can't eat.
It
blood.
dies, right? Okay, so this we call an inhibitor, specifically a competitive inhibitor. They're both the insecticide and the acetylcholine or acetylcholinesterase are both competing for the same space, even though this acetylcholine is interacting with this amino acid and this insecticide is interacting with this amino acid. Yes, it just needs to get in the way. That's all that matters. It just needs to get in the way. Cool? So then one day, there was a mutation. So there was two mosquitoes, and they were madly in love. One was named Jimmy.
Dang it, Jimmy.
Okay. The other one I don't know the name of, but she was just a small-town girl living in a lonely world. All right?
Why all this heteronormativity, Luke? Why?
Because that's how it is.
She's a tall girl.
Okay. When they had a baby, there was a mistake in copying the code for this amino acid.
You should hold that up to the camera.
There was a mistake in copying this amino acid. So it went from something like this to an amino acid that had this extra group on it
Will you point to it?
right here. All right. Now, did this cause any problems? Let's see. We have our whoops, sorry, I did that wrong. Right there. Okay, so we have our acetylcholine come in, and hey, look, it can interact. So can we break down our acetylcholine?
Yep.
Okay, but then the killer of love, okay, tried to come in, and that extra hydroxyl group caused a problem. This can no longer fit in the active site.
No.
Right. So this mosquito in this enzyme developed a mutation. Now this mosquito can break down acetylcholine. But because this insecticide is slightly bulkier, this mutation, this extra carbon with oxygen attached to it, blocks this from working. Okay? So we see a couple really, really important ideas here. First of all, that enzymes have specific groups that interact with substrates. So it's not just enough that they fit in this size. They have to interact charge-wise with the substrate. So this, the acetylcholine, has a hydrophilic interaction right here with the enzyme. Okay?
I think I just what did you say again? That's kind of how they have to interact. Charge-wise.
This has a hydrophilic interaction with the enzyme, right? So it's not just this can fit in several directions in this amino acid or in this active site, but it's also about charges. Okay,
And you call that the substrate.
this is the substrate. This attaches there.
The little nugget is the substrate.
What?
The little nugget is the substrate.
Not call it a nugget. What's it called?
Okay,
Nope.
okay,
No,
that's what I thought.
this is not a substrate.
Okay, cool. That's
So
what I thought.
this was a mutation.
So once you put that on,
Yeah.
it's representing a separate enzyme.
This is another enzyme. Okay, so I have this enzyme, and then they had a baby, and the baby has this enzyme.
Okay, cool.
Okay,
The
and
enzymes love each other very much.
right,
Aww.
and in this enzyme there is a specific different amino acid there. Yes. Okay, in this amino acid blocks the insecticide from being able to bind, meaning that this mosquito can break down acetylcholine, but is resistant to the effects of the insecticide. So now this mosquito, again being a small town girl living in a lonely world, what? Now falls in love with other mosquitoes,
Oh, come on.
and those mosquitoes all have this.
That sounds like bad news to whoever invented the insecticide.
Humans.
But the guys, those are Jews.
Right. Okay, so this is our story. Now, there's
I'm
one
missing-
part here. If like there was another part of the enzyme, let's say up here, that I could jam something into, that made this top part fold down and cover the active site,
Uh-oh.
that would also be an inhibitor.
These are called inhibitors.
So anything that blocks the active site is going to be called an inhibitor. Now, there's two different types of inhibitors that we've seen. So we have this one, which blocks the active site, and we call that a competitive inhibitor. It competes for the active site. It's not competing. All right? It competes for the active site. Another molecule that bound up here and changed the active site would be called an allosteric inhibitor. ALLOSTERIC.
Say again.
ALLOSTERIC. Allosteric inhibitor.
Oh, yeah, no.
Okay, so an allosteric inhibitor is different than a competitive inhibitor. Both stop the enzyme from working. One blocks the active site directly. The other causes the active site to change so that it cannot bind.
Which switch?
Allosteric is the one that binds away from the active site,
Okay.
and the competitive inhibitor is the one that binds at the active site.